G'day everyone. Today we're looking at simultaneous equations. This basically means two equations and both of them are true at the same time. And there are three methods to solving these. There's a method called substitution, one called elimination, and a graphical method as well, which we'll be using the CAS calculators for. In this video I'm going to basically just give two examples, and I'm going to use all three methods for those two examples. Yeah, that's basically all I'm going to do. So here's the first example. We have two equations, the 2x minus y equals 4. Actually, maybe I'll write example 1. And a second equation, x plus 2y equals minus 3. So we have to figure out what value of x and y will work so that these two equations are actually going to be the same as each other. Or which ones, so they're both true. So there's only going to be one x value and one y value that gives these to be the same. Okay, so first off, let's use substitution. Now the general idea of substitution is if you make one of the variables the subject, then you can put that into the other equation. Okay, that sounds a bit complicated, but let's take a look. Let's first take this first equation. Okay, 2x minus y equals 4. And we're going to make y the subject. And I'll make y the subject by first adding y to both sides. So that's 2x equals 4 plus y. And then I'm going to take 4 away from both sides, which leaves y by itself, and we have 2x minus 4. Okay, so now we have y is equal to this stuff here. And because the y in this equation has to be the same number as the y in this equation, what I can do is instead of writing y in this equation, I can write 2x minus 4, because that is y. So I'm going to take my second equation now, and instead of writing the y, I'm going to write 2x minus 4. Okay, so what I've done, I've substituted in y from one equation into the other equation. And now I'm left only with x's in here, so I can solve this. X plus, now expanding my brackets, that's 2 times that and 2 times that. 4x minus 8 equals minus 3. So on this side I've actually got 5x minus 8 equals minus 3. I'll add 8 to both sides. Equals 5. Divide both sides by 5 gives x equals 1. Now that I've got x equals 1, I still need to find what my value of y is. So I'm going to substitute x equaling 1 into one of my equations. Doesn't matter which, I'm going to just throw it into this first equation. So let me write it down, 2x minus y equals 4. But with x being 1, that's 2 times 1 minus y equals 4. Which is 2 minus y equals 4. So I'll take 2 away from both sides, and I'll multiply both sides by minus 1. There we go. So my final answer is, for xy, is 1 minus 2. X is 1, y is minus 2. So there we go, that's substitution. Let's quickly run through what just happened. We made one of the variables our subject, and then we substituted it into our other equation. And then once we had our answer, we substitute that back into one of the equations to find the other variable. Alright, so let's try the elimination method. Also, just so you know, my housemate is cooking up bacon and eggs, so it might get noisy in the background. Worry not, though. Alright, so elimination. Okie dokes. So, the gist with elimination is that you can add or subtract the whole equation from the other whole equation. So I'll show you what I mean by writing these two equations out again. 2x minus y equals 4. And x plus 2y equals minus 3. So I want to be eliminating either my x or my y. So let me show you what would happen if I added these two equations. I would get, for my x, I would get 3x. For y, I would get plus 1y. And for my constants out here, I would get a 4 minus 3, a 1. Now, I haven't eliminated x or y. X and y are still there. Okay, so I haven't done elimination yet. To eliminate things, I noticed that if I had this one to actually be a minus 2y, it would cancel out with this plus 2y. So what I'm going to do is I'm going to multiply this first equation, this whole thing, by 2. And that works because I've multiplied the left-hand side and the right-hand side by 2. So let me write this elimination sum out again, but multiplying this first line by 2. It would look like this. 4x minus 2y equals 8. And x plus 2y equals minus 3. So let's try adding these two equations again. So we've got 5x now. Now minus 2y and plus 2y gives 0. So that's a 0 plus 0. And 8 and 3 gives 5. So you see we've eliminated the y's. We're only left with x's. So we have just a 5x equals 5 here. So x must be 1. Okay. Next, we think back to our original two equations, and we think, how could we have eliminated the x's instead? And that is if we multiply this bottom equation by a minus 2, because that would give this a minus 2 coefficient out here. So let's try that. Writing them out again, but with the bottom one multiplied by minus 2. So that would be minus 2x minus 4y equals plus 6. Okay, so now we'll add those. And the x's this time, the x's will be eliminated, giving us just minus 5y equals 10. So divide both sides by minus 5. So you can see that y is minus 2. So we have an x equals 1 and a y equals minus 2, just the same as if we had used our other method. Okay, so there's our elimination method for you. And lastly, the graphical method. And this one we basically have to use a CAS because it's too hard to do it by hand. So let's show you what I mean. You need to get up a graphs page. Add a graphs page. And we'll type in our two equations. So we had... by the way, this is a bit of a pain because you have to always have them in terms of y. I forgot to mention that. So back here we need to make both of our equations in terms of y. Bit of a pain. So we have 2x minus y equals 4, and we also had x plus 2y equals minus 3. So this one here is a y equals 2x minus 4, and if we put this one in terms of y, that's going to be a 2y equals minus x minus 3, y equals minus half x minus 3 on 2. Okay, so those are the two equations that we need to put into our CAS calculator. Alright, so let's pop those in. We have the 2x minus 4 one. There that is. And to put in a new equation, you just press tab. So we have a minus a half. Let me use my fraction thing. Minus 1/2 x minus 3 on 2. There we go. And you can see that there's a point of intersection. So whatever that coordinate is there, that is our solution. So we can go menu, analyze graph for the intersection. Now it asks for a lower bound, so we put it over on the left, and an upper bound. And there it is, the intersection is +1 minus 2. So we'll just write that down. 1 minus 2. Uh, 1 minus 2, which is the same solution that we had for our other methods. So those are our three methods. You may need to rewatch this video to really understand all three of them. But what I'm going to do now is just one more example at which I'm going to use all three methods for, similar to what I did before. I should mention to you, however, that a key part of doing simultaneous equations is understanding which method is going to be the easiest one to do at the time. So let's suppose we had these two equations, so two new equations. Okay, so here are two equations, and our question will be, which is the easiest method to use for these? Well, you might think substitution, because you've already got the y as the subject. So you've already got one of the variables as the subject. So you could put all of this in for y. Put all this bit here in to the y. So let's start by doing that, the substitution method. Okay, so to put all this in for our y, we will just have a 5x minus 4, which is where the y is, now equals 3x plus 6. So we'll take 3x from both sides, making this a 2x minus 4 equals 6. Now we'll add 4 to both sides, and we'll divide both sides by 2. So there we go, x is 5. Now I've got to substitute the 5 back in to one of these. I'll just choose this second one, just for no reason. Y equals 3 times 5 plus 6. 3 5s, 15 plus 6. So y is equal to 21. There we go. So my final answer is 521. And I'm done. So there's the substitution method. Now some of you may think the elimination method will be a good one to use because we've got a y and a y, so they will eliminate very easily. So let's try the elimination method. So what I'm going to do for the elimination method, well, let's just write down our equations. Whoops. Y equals 5x minus 4 and y equals 3x plus 6. So what I'm going to do first is I'm going to multiply this second one by minus 1. So as I write them down, that one's going to be by minus 1. So it's a minus y equals minus 3x minus 6. Now if we add those, the y's get eliminated. 5 minus 3x is 2x, and minus 4 minus 6 minus 10. So rearranging this gives us 2x equals 10 by adding 10 to both sides, and then x equals 5, which is just like what we would have expected from our other one. Okay, next up, instead of doing that, to eliminate my x's is going to be a bit tricky because I need to get the same number, the same coefficient in front of the x, but with one of them negative. So I'm going to multiply this side by 3, and I'm going to multiply this side by minus 5, because then I'll get a 15s going on here. So I'll show you what I mean when I write it out. So this one by a 3 gives 3y equals 15x minus 12. And this one by minus 5 gives us minus 5y equals minus 15x minus 30. So let's add these together. We have minus 2y. X's get eliminated, and we have equals minus 42. So now I need to divide by minus 2. So the minuses will cancel out, giving us 42 divided by 2. So y is equal to 21. And our final answer is 521, which is the same as before. No surprises. Okay, next up, our graphical method. Graphical method. And the graphical method is going to be easy this time because if we look at our equations, they are both have y as their subject, so we can put these into our CAS really quickly and easily, which I will do now. So get up a new graphs page, put in our two equations. We've got a 5x minus 4, and tab for a new page. We've also got a 3x plus 6. Okay, so you'll notice here we have no intersection, and that's because our window is set poorly. So we need to go into menu, window/zoom, and we could zoom out until we found the intersection. There we go, we've zoomed out and we can see it there. So now we need to go menu, analyze the graph, intersection, go on the left side of it for the lower bound, right side of it for the upper bound, and there's our intersection, 521, just like we expected, because that was our answer for the other ones. So there we go, that is 521. Whoop. 521. So there you go. There's all three methods for that one. So please use these examples to help you out. Remember, you only need to use one method at a time to solve the questions in your textbook, and the hard part sometimes is just choosing which method you're going to use. So all the best for that, and I'll see you in class.